This is a particle podcast. WA Science told different. Powered by SciTech.
This is for the ASMR crowd.
Oh, that was nice, actually.
Good evening, everybody. My name is Leon.
And I'm Beth.
And welcome to Please Look Up, your monthly deep dive into space news.
And commentary.
Recorded at SciTech on Wajak Noongar land. And welcome. This is the second episode of the season for 2025.
Yeah, it's exciting. It's exciting. Off to a strong start, Beth.
To a strong
well done.
start, yes.
So, Leon, what's up tonight?
The question of my life. Well, the parade of planets that we spoke about last month, it's still going.
Yay!
And it's gotten slightly better as well, or getting slightly better, I should say. So last month, you may recall, we spoke about seeing all of the planets except Mercury in the nighttime sky.
Mercury letting us all down.
Yeah, well, Mercury has finally pulled its weight, and it is now also going to be joining the remainder of the planets in the night sky.
Hey!
So you can, in theory, go outside sort of middle of February and see every single planet all lined up across the sky. And, of course, provided you look down between your feet and look at the Earth as well, you'll see all the planets in the solar system.
That's pretty awesome. So if I'm looking for these planets, let's, just in case people missed last month, should we start watching the sunset?
As we always do.
As we always do.
Yes.
And then what are we seeing?
So in the west, there's sort of the trio, actually. There's the extraordinarily bright Venus. It's
always.
reaching its maximum bright. It's unbelievable how bright Venus is.
So
you just
awesome.
go out and have to have a look at it.
You can, well, I mean, Venus is bright enough that you can see it before the sun has set. Like, don't even wait.
Yes,
you can see it in daytime, pretty much.
Yeah, you can see it during the day. Yeah, like in the middle of the day, you need to know where to look. But yeah, at like 6 o'clock or 7, quarter to 7, as the sun is starting to set, you'll definitely see Venus there. Yes, and then not far from Venus, sort of to its, if you're looking at Venus in the west, to its lower left, for lack of a better description, you'll see Saturn. It's it's not as bright, but it's there. And
it would look bright if Venus wasn't being a show-off so
That's
close.
right, yeah. But it's definitely there. There's no other kind of bright stars nearby that are going to, you're like, oh, is that Saturn or is that a star? It's probably Saturn. And then right down near the horizon, I said Mercury was joining the show. If I'm being honest, it's not trying very hard.
Okay. I mean, it's difficult for Mercury. It's so close to the sun that we just can't see it very well.
That's right.
Because the sun is too close.
The sun is too close.
And don't look at the sun, everyone.
No,
that's a
right.
bad plan.
Bad idea. But yeah, for a couple of weeks during the middle of February, so from about, the 10th to the 20th, 25th maybe, you'll also be able to see Mercury there. It's very low on the horizon and it's not up for very long, so you need to be out sort of between 7:30 and 8:30 to see it.
Okay.
After that, and it's not even completely dark by 8:30 and the sun and Mercury will have gone.
Yeah.
But it is there.
Okay, so probably best to see that maybe like from the beach where there's nothing in the way on the horizon.
That's actually a pretty solid idea.
Yeah.
I'm not really a beach person, so the idea of doing that never occurred to me, but yes.
No, I think, I've always found it a little bit easier because often, if I'm anywhere else, there's a tree or a house in the way, and I can't actually see everything. Whereas, beach is nice and flat horizon there.
That's it's not a bad idea. There you go.
Yeah.
So yeah, you've seen Mercury, Venus, and Saturn, and then you are turning to our right.
It's so weird when we turn right.
I know, we always turn left. It's weird. But yes, we turn to the right, and we look to the north, and high up in the northern sky. It is quite high up, like it's not just on the horizon. You need to look up, and you'll see the big, bright, biggest planet in the solar system.
Jupiter? Sorry, I didn't realise that I was expected to talk to that. I thought you were going for it.
No.
I was like, oh, it's a dramatic pause? No, it's not a dramatic pause. It's me. Hello, Jupiter, biggest planet in the solar system.
Yep, and it's there. It was there last month. It'll be there next month. Can't miss it. It's pretty exciting to look at. And then just a little bit further to the right is the red planet Mars.
Yeah.
Now, funnily,
missed one though.
I missed two.
Yeah.
But we'll get back to that in just a second. I did mention last month that Mars was at opposition in January.
Yes.
And that was its brightest thing. It's dropped in brightness a full factor of 2 between last month and this month. So it's still there, but it's not as obvious as it was last month. But yes, we did miss 2 planets, Uranus and Neptune.
And that's because you can't really see them.
Yeah. They are there.
You can see them if you have some really good binoculars or a telescope.
Yes, that's right. So in between Venus and Jupiter, as we turned from facing west to facing north, and we draw an imaginary line from Venus to Jupiter, across that imaginary line are Uranus and Neptune.
Yeah.
But, yes, that's right. Without a telescope, you won't be able to see them, and even with a telescope, you really need to know what you're doing.
You need to know where to point.
Yes, but they are there, so don't you worry, they are there. And so, yes, you can, in theory, see all 8 planets of the solar system, again, assuming you're looking down as well, in the night sky.
So there's a thing that I've seen a little bit about online about this, and people are calling it a planetary alignment. And I've seen a few images which also I think are a little misleading about what the planets will actually look like in the sky, because I've seen a lot of images where it looks like they're stacked up on top of each other, all like in one concise part of the sky.
Ah, right.
And I don't know how much of that is just, you know, a little bit of artistic liberty, like these are all the planets, thank you, now we know what they look like. But like, and also quite often there's a fair amount of detail in those pictures as well. It's like, that is Jupiter, it is stripy. Like, it's not like that. They do look like stars.
Yeah, they're just bright things in the sky.
They're just very bright things in the sky.
Yeah.
And the line that they are in across the sky really does go from the western horizon all the way up and across the sky to, well, sort of nearly northeast.
Yes, that's right.
So
they are lined up in the sense that, yes, you turn as you draw this line out across the sky, but they're not lined up behind each other, one after the other after the other.
Yeah, or like in a little neat stack that only spans about a hand span.
No.
So
you're almost a full 2 outstretched arms.
Yeah, so I just wanted to clarify, because I've seen some pictures going around,
right.
and I think that they might not be helping people.
No, it's not. And it's also worth mentioning, in sort of 3-dimensional space, if you could lift yourself out of the solar system and look at it,
yes,
this line between all the planets would zig and zag and up and left and right. And
yeah, it's also not, well, because also if they were all actually in a line, we wouldn't be able to see anything past Jupiter, because Jupiter would be in the way.
Yeah. Good point.
Yeah. And Jupiter's the big one, so you can't see anything behind it.
Yeah.
So yeah, top-down view of the solar system, they're also not in a line.
No, that's right. Alignment is it's a useful word if you understand the context of it, but that's right. If it's not communicated properly, then you can be forgiven for being mistaken.
Yes. So yeah, just thought I'd clarify, but it's still pretty awesome.
It is.
Yeah, a fairly rare occurrence.
Yeah, that's the thing, given that there's no real definition of an alignment and of how many planets, but yeah, seeing all 8 of them like this, or all 7 in the sky, is quite uncommon. Yeah. It's not uncommon to see a few, and there's always at least one, almost always at least one somewhere.
Yeah, and also like over the course of a whole night, being able to catch all of them is not, that's a lot less unheard of.
Yes, that's right.
But yeah, the particular way that it lines up right now, where basically just after sunset you can see all of them, is very exciting. So
yeah, speaking of, the time you need to go out is between 7:30 and 8:30.
Yeah.
If you want to see Mercury. If you don't really care, because it's, as I said, it's a bit shit, you can go out a little bit later.
Mercury.
8:30, 9 o'clock.
Yeah.
There we go.
So one of the things that I was going to say when we were talking about where you find Jupiter, I think brings us to our other squad of what you can see in the night sky at the moment.
Yes.
Because Jupiter is sat between the horns of Taurus.
That's exactly right.
So we've got some fun constellations going on in the northern sky. So once you've followed your parade of planets around, there's some fun stuff going on.
Yes, as you said, Beth, we've turned and faced to the north and we found Jupiter. And yeah, the horns of Taurus, the way you look for them, just look above Jupiter and you'll see like a little arrow-shaped pattern of stars.
Yeah, a little V.
A little V, that's a better description, actually, V. And those are the horns of Taurus the bull, and you can sort of extend them out into the sky if you wanted to.
Yeah, it's like, again, we say the horns of Taurus. Some people say that the V is the face, but there are actually 2 really far fainter stars way out, which are the horns.
Yeah, whatever.
Yeah.
There's a pointy pattern.
There's a pointy bit, and that's Taurus.
Yeah, and then obviously Taurus goes hand in hand with the story of Orion, who's sitting just above Taurus in the sky at the moment. You look for the 3 stars that make up the belt, and then you kind of fill in the dots from there.
Yep.
But then Orion is also known to go hunting with his 2 hunting dogs, which are Canis Major and Canis Minor.
Canis Minor, one of my favourites.
Yes. If you, I'm going to paint a picture of Canis Minor for those of you who don't know what it looks like. So I want you to picture a star in the sky.
Okay.
And then
I've got
about
that in my head.
Maybe 3 finger widths away, picture another star.
Yep.
Now draw a line between those 2.
Okay, I've got my line.
And it's a straight line. There's no other way of joining those 2.
Yep.
And that picture, well, Canis Minor, what do you think? You know more Greek than me. What do you think Canis Minor is?
Well, are there more stars that I need to...
No, that's it. Just those 2.
But Canis is dog.
Yep.
And Minor is small.
Yes.
So this line...
is a dog.
Is a dog.
Yep. Yeah, the thing with constellations is you're almost better off thinking of something that's as wrong as possible, and you'll probably be more close to what it's supposed to be than...
Look, I'm just saying, the ancient Greeks had a god called Dionysus who was the god of wine. So maybe Dionysus was involved in the naming of that particular constellation. Although I have had someone in the planetarium before tell me it's a sausage dog.
There you go.
So there you go.
It's a dachshund.
Yeah.
Were dachshunds bred?
I don't
back then? I don't think they were.
I
Doesn't
don't
matter.
think so.
To spot them in the sky, they're next to Orion, both Canis Major and Canis Minor. Canis Major, we'll talk a little bit more about later. Spoilers. But it's you look for the really bright star next to Orion. Obviously, that's Sirius. That's the dog star, and that's Canis Major, and then Canis Minor is sort of underneath.
Yeah.
And use our best friend Stellarium to help you.
Yep.
But once you know that they're there, they're very easy to spot.
They are quite easy to spot. Yeah, I was thinking that about Canis Minor in particular because I thought, like, it's a straight line in this. It's 2 stars. I'm not going to be able to see this, but actually, it is fairly obvious because the other stars around there aren't very bright. Like,
No,
you've got this
right.
big, obvious trio leading basically from the Pleiades to Canis Major, and then there's just sort of a couple stars hanging out underneath.
Yeah.
I'm like, oh, there you go.
There they are. Yeah, once you you can't unsee it. But this does lead me to a nice little side quest for people, which is because they are so easily identifiable, it's really obvious when something else is there that's not supposed to be there. And what aliens could be. I guess a subset of this. What I'm really specifically talking about is satellites.
That would make more sense.
Satellites we talk about occasionally, but this is a really great way to practice spotting them because they are so obvious, the constellations, that if you just go out and look at Orion and wait, a satellite will come to you, and it'll be so obvious that because you're like, well, that's clearly not one of the 3 stars in the belt, and it's not one of the horns of Taurus, and it's moving because satellites move, and they just stand out. So the way I tell people to go and spot satellites is go outside and find Orion and Taurus and Canis Major, and then just wait. Check Facebook for a minute, look back up again. Is something there? Nope. Go back down. Post on Twitter, look up again, and I'm looking at Orion, but there's this new bright object there, and it's moving through, and I can tell because I know what Orion looks like, because Orion is so obvious that this new thing stands out, and that's the easiest way of spotting satellites I've ever found.
Oh, well, that's a pretty fun side quest. I'm going to have to tally how many satellites I spot this month.
Yep.
Should we have a contest?
All right, let's do it.
Yeah,
Right.
Let's see who spots more satellites in the next month.
Okay,
We'll return to you in the March episode, satellite spotting. I'm literally going to make a note of that right now because otherwise I'm going to forget.
Now, to be clear, you have to do this for about an hour or 2 after sunset. If you're out too late, you won't see them because the light you see on a satellite is not the satellite's own light. It's reflected sunlight. So you need to be out not long after sunset if anyone else wants to join us on this satellite quest.
How does that work with the International Space Station? Because I swear... maybe it's just me not knowing when sunrise is, but I swear that some of the timings we give for spotting the International Space Station are 2 in the morning, or are they just 3, 4 in the morning and that's actually nearly sunrise?
They can get pretty early. There's a couple coming up in February at about 20 past 4 in the morning. No, they never quite go as early as 2 or 3. I mean, the International Space Station does pass overhead at that time, passes overhead at all times of day. But at midnight or 2 o'clock in the morning, we just wouldn't see it.
Okay.
There are lights on board the ISS, it's worth clarifying, just that they're so faint that it's not enough. No. And then let alone any other satellite that doesn't have lights on board or, barely anything on board.
Awesome. Okay, so spotting satellites in our post-sunset, pre-dawn.
Yep.
And then we've also got our planet show and Orion and company.
Yep.
Anything else going on in the night sky this month?
There is a quick mention. I will mention there's a meteor shower.
Ooh.
It's not the biggest or brightest that's ever out there, but it's very handy because it's called the Alpha Centaurids meteor shower.
Okay, so using our nomenclature, Centaurids, Centaurus.
That's right. And in particular, Alpha Centaurids would be...
Alpha Centauri?
Alpha Centauri,
hey.
Yeah. So go outside and find Alpha Centauri, the
Which
closest star to us.
Well, I find this quite fun because... we always say use Alpha and Beta Centauri to find the Southern Cross. But if you're trying to find Alpha Centauri, find the Southern Cross and there's a couple stars pointing at it and there you go.
That's not a bad idea. Yeah, work backwards, yeah. And it's just a nice little one. So they're not coming from Alpha Centauri, but just by the angle of the dust that is hitting the Earth, it looks like they're coming from that direction. That's why we call them the Alpha Centaurids. So they peak on the 8th of February. There's not very many of them, maybe one every 15 minutes.
Okay.
But Alpha Centauri is up all night from Australia.
Yeah.
It never dips below the horizon, so it actually doesn't matter what time you go and have a look.
Okay.
So just keep that in mind.
That's a good one to know. If you've missed the satellites,
yeah,
and you're looking south, and there's something moving
Very quickly.
very quickly, it might be
A meteor. There you
awesome.
go.
So there was one part of our night sky that we sort of skimmed over because it is
Constellation
Orion. So Leon, tell us about Canis Major.
Canis Major, yes. So we briefly touched on it. Well, we mentioned Canis Minor was the small dog. Canis
Yes.
Major, obviously, is the big dog.
Big dog.
And you look for it in the night sky in the north. It's in the north during February at about 9 o'clock northeast.
Mm-hmm.
And you're basically just looking for the big bright star of Sirius,
Yeah.
which is. I said it's a dog. It does look more like a dog than Canis Minor.
Yeah.
Sirius is sort of the neck of the dog, and then if you carefully construct it, you can there's some stars nearby that make up its front legs, and you can make a back
Yeah.
and some back legs.
I've also seen versions of it where, like, if you can connect some of the fainter stars, he's got like a little triangle head as well.
Yeah, that's
Yeah.
right. Yeah, if you have really faint stars.
Yeah.
But yeah, it's the mythology. I'm sure you can tell us a lot more about.
Yes.
The Sirius itself is a really fascinating star. So it's the brightest star in our sky for two reasons. One is it's already quite a bright star. It's about intrinsically about twice as bright as the sun, but also it's really close. It's only, I think it's like the sixth closest star to us.
Yeah, it's only 8.6 light years away.
Yes, that's right.
So it's like if you could put it next to another star, like actually next to, it probably wouldn't be. Like if you put
Yeah.
it, there are technically brighter stars in our night
Significant.
sky,
Yes, that's right.
but they don't look brighter to us because they're really, really far away.
They're further away. That's right. Yeah. So, but because of that combination, it's both. But it's an interesting one because it's actually a binary star system. It's two stars.
Yeah.
But the companion star. So the main star is a sort of a sun-like star, bit bigger, bit hotter, bit brighter than the sun.
Yeah.
And then it's got this itty bitty tiny little companion.
Isn't it like a white dwarf?
A white dwarf, yeah. So, which was once itself another star about the size of the sun. The life cycle of stars the life cycle of sun-like stars is that they burn for a few billion years and then they swell up and they throw off their outer layers, and then everything that's left over is just the tiny little core of the star, which we call a white dwarf.
So this does lead me to something that came up in my research about Sirius, which is colour controversy.
Oh, okay.
Yes. So this is what you're saying about like the white dwarf being a different stage in a star's lifetime is one of the theories behind this controversy,
Ooh, okay.
which is basically in about 150 AD, so like a Roman period, but a Greek Egyptian astronomer. It's Ptolemy.
Oh, yeah.
Yeah,
Classic Ptolemy.
quite a famous. So he said in one of his books that Sirius was reddish. So he mentioned it alongside Betelgeuse, Antares, Aldebaran, Arcturus, and Pollux,
Wow.
which
Which are what I would call red.
are red. But then also, not all ancient observers seem to see Sirius as red. There is also a 1st century poet who described it as sea blue. So did someone in the 4th century. But is it possible that somewhere between, the 1st century, it's
That it changed colour.
yeah.
Ah.
So this is like it's possible, because there's a lot of like weird discrepancies in like some people saying one way and some people saying another. So there was a poet, Aratus, Cicero, Germanicus, all called it red.
Oh, wow.
But Aratus, Cicero, and Germanicus weren't astronomers. But some people, Seneca said it was actually a deeper red than Mars. But then people are like, well, that's actually a poetic metaphor
I'm starting to think that.
instead. So it's like, oh, is it red? Is it not? What was Ptolemy doing?
I reckon that it's probably like a lost in translation thing.
Yeah, probably.
So, like, based on my knowledge of the way stars work, they can and do change colour over their lifetime, but we're talking over billions of years. A star, if anything that happens faster than a period of a few centuries is unbelievably fast for a star.
Yeah.
And I don't see how it could. I'm reminded of a quote of like the importance of language and how it evolves over time, that
Yeah.
In a few thousand years people are going to be so confused about the difference between a butt dial and a booty call.
Yes. Or literally and literally.
Yeah, exactly. So I think this is, either a poetic metaphor or a translation, or both, that have become lost over time. I severely doubt the star was ever actually red. But it's also, isn't that the whole thing of like, I don't know, is this true or not? Did ancient Greeks not see blue because they didn't have the vocabulary for it?
Well, I don't know about Greek, because they are like a fairly ocean-going people.
Yeah.
And I know that some of that, like, this is outside of my area of expertise, by the way.
Likewise,
But I know that there are certain nations where they don't distinguish so much between like the green of trees and the blue of sky. But I think that that's more inland nations. But
Yeah, right.
I'm not sure.
Yeah, we're getting well beyond our area of expertise.
Well, we are. I do still have stuff about Sirius, though, which might be related to this redness, because the Greeks used to see Sirius as a morning star at the start of summer. So this is also maybe where the term starstruck comes from.
Ooh.
Because they thought that Sirius, because they had like really, really hot summers, they thought that one of the things that Sirius caused was it made plants wilt, men weaken, and women to become aroused.
Oh, wow.
So this is one of those, so like maybe this poetic red comes from that, like, you know, the bringing the, well, also just bringing the summer, bringing that like hot,
I see what you mean.
You know, and so the season of summer became known as the dog days, named after the dog star.
Yep.
Because that's what they saw. And there was actually an island called Ceos, who offered sacrifices to Sirius and Zeus to bring cool breezes. And we know that Sirius is really culturally important to that island because we found 3rd century coins depicting Sirius with emanating rays coming out of it.
That's amazing.
Yeah, it's pretty cool. And like the Egyptians also had a similar connection to Sirius.
I remember this.
Yeah, so they worshipped Sirius as the goddess Sopdet. And they saw Sopdet as like a guarantor of fertility because Sirius rose above Cairo on the 19th of July, which lined up with the annual flooding of the Nile, which was the thing that brought, fertilized the fields. Because Sirius, because of its location in our night sky, holds very consistently with the solar year.
Yeah, okay.
So yeah, there's this Greek, there is this Greek and Egyptian association with certain weather patterns to Sirius as well. Yeah, and of course. Because it's so bright.
And that's, it's such a fascinating thing that obviously we get seasonal changes and yearly variations because of things within our solar system, Earth's motion around the sun, the tilt and things like that. So very localized things are causing these effects. But in the same way the seasons change in a very regular and predictable pattern, the night sky changes with the seasons. Yeah. And so, it's no surprise that people associate things in the night sky with the things around them. Yeah,
especially when, you're an ancient person who doesn't know about the tilt of the Earth's axis, but you do know that every time that star comes up, it's about to get really hot.
Yeah, that's right. So, and
that's a way more, logical link, so I completely understand that.
Yeah, and that is a thing that's, fairly consistent across many ancient cultures is the connection with the sky and their daily lives and the world around them.
Yeah, especially seasonal because the sky is seasonal.
Yeah, true.
Well, so one of the other things about I'm kind of that's focusing a lot on Sirius in particular, which is very easy to point out as this bright star whose name is actually from the ancient Greek for glowing or scorcher as well. Yes. So that's that association, and that's where I'm like, is that red? Is that mistranslation scorcher, red hot?
I'm leaning towards that. But
but the concept of that group of stars as a dog is obviously ancient. It's an ancient Greek constellation, but the Babylonians didn't see it as a dog. They saw Sirius as an arrow aimed towards the constellation of Orion, and the southern stars of Sirius plus part of Puppis as the bow shooting southern stars of Canis Major.
Yes.
And part of Puppis as a bow firing the arrow, because the Babylonians did see Orion as a person.
Yep.
So even though the dog was not a dog for them.
Yep, they still see Orion. Yeah, I think just about every culture sees Orion as a person.
Yeah. But the ancient Arabs saw Canis Major as a dog. But I found out something in my research about the fun relationship between the Greeks and the Romans and all of the stuff that they chat about.
Yes.
How some of it is really similar and some of it's clearly just been like stolen a little bit or mistranslated. So the Greeks saw Canis Major as Lelaps, the dog, who was a gift from Zeus to Europa.
Ah.
The Romans saw Canis Major as a dog guarding Europa from Jupiter, who is Zeus.
Yes.
So I don't know what happened there. What happened between the Greeks and the Romans there?
Two different, very different versions of that story.
But we can agree it's Europa's dog.
There you go.
Yeah, that's what the Greeks and Romans can agree on. It's
perfect.
Europa's dog, but it's either a gift from Zeus or a Zeus-proof dog. I don't know which one.
Perfect.
But yeah, I think that pretty much exhausts my my weird aside into stuff that's kind of space related but is actually history and etymology. So
I do like that. I've got an interesting thing about Canis Major.
Oh.
So when you make the pattern of the dogs amongst the stars, near the hips of the back legs, it's a very faint star from Earth. There is a star there called VY Canis Majoris, which just to...
That sounds exciting.
Yes, I know. To understand why it's got that name, firstly, you know how we talk about how the bright star gets alpha, Sirius is called Alpha Canis Major, for example, and then beta, and once you run out of Greek letters, you go onto the English alphabet, and then it becomes A through to Z, and then A, A, B, AC, and so on.
So VY is a long way down that list.
VY is a long way down the list, so it's very faint.
But that's just including... So once we get to that point, isn't that just including all of the stars in the IAU boundary?
Yes, that's right.
Of Sirius.
Yeah, we're trying to number every single star in that boundary.
Yeah.
VY Canis Majoris is very faint from Earth, but when looked at and understood astronomically, it turns out to be possibly one of the largest stars in the entire universe. It's
in the universe.
Yeah, that we've ever discovered.
Whoa.
Yeah, it's kind of hard to measure the size of stars because they're so far away. So every sort of list of the biggest stars always comes with a bunch of caveats.
But at the moment, we think it's this one.
Yes, that's right. And even I was confused about this because I'd heard it had been overtaken by another star called UY Scuti.
I was literally about to say, I thought there was another star which was something Y. So I'm glad that you explained that name nomenclature because I thought for a second that big stars are just called something Y.
Oh, right. No, just coincidental that they both happen to end in a Y.
Just so happens.
But yeah, when I looked up UY Scuti, there must have been some new measurements because it's now known to be smaller than VY Canis Majoris.
Whoa.
So to put into context, if you replaced the Sun with VY Canis Majoris, the surface of the star would extend beyond the orbit of Jupiter, almost to the orbit of Saturn. So
that's big.
Yeah, it's big. And
so to give some context as well, some maybe stars people are more familiar with, like Antares and Betelgeuse, they're red supergiants, and they would kind of maybe touch Jupiter.
Right.
In their size?
Yeah. I was trying to think of another sort of analogy that might be a bit more tangible. Imagine you're holding a beach ball that's a metre across.
That's a big beach ball.
Yeah. So, a very big beach ball.
Yeah.
And that's the Sun.
Okay.
So, by comparison, VY Canis Majoris would be a beach ball 1.5 kilometres across.
Oh gosh, yeah, that's a lot.
Enormous, yeah. It's not even just a little bit bigger. You can't even see the curvature of it.
That's the whole beach.
Yeah, from the context of the Sun. Yeah, it's enormous. As I say, it's kind of hard to measure.
And that's a big beach ball to start with.
Yeah, that's right.
Wow.
So that's the sort of comparison we're dealing with. So I'm not really sure what the upper limit is on how big a star can be. What happens is, as stars get so big, the material that's right on the outside of the star is very, very far away from the core of the star, where you can essentially consider the gravitational force to be sort of emanating from. And so the outer layers eventually, there's this cutoff point where they just kind of drift away. So so it can only get so big before it just falls apart.
Yeah.
But this is right on the upper limit of how big a star can be.
So is it in our galaxy?
It's in our galaxy, yes. But it's very
that
far
just
away.
feels good, doesn't it? It's in our galaxy. We got one of the big ones.
Yeah, we got one of the big ones. I mean, to be fair, there's probably
easier
stars of that size in every galaxy. It's very hard to study individual stars in other galaxies.
It's easier for us to study stars in our own galaxy because they're closer. There's probably be a
Silly
bigger one
Milky
further
Way.
away. But for now, we're taking it.
Yes.
Maybe at the Star Olympics 2050, some other star
Some
will
other
win. But
the
they
Star
cannot
Olympics.
take away Star Olympics silver 2025.
Oh dear. That's all I've got for Canis Major. But
Alrighty.
we did start last month on a new segment.
We did.
I think it's called Star Stories. We'll go with that.
It's
Planet
star
mythologies.
stories, nothing to do with stars.
No.
Let's talk about planets.
Yeah. But yeah, we're going through the planets because they're all in the sky at the moment. We're going through the planets and we're just sort of covering some of the more storytelling side of, the historical stories that we
Yeah.
talk about these planets.
So this is I snuck into Planetaria through being a Greek mythology nerd, but it's one of the things that for me it really helps anchor some of the physical knowledge is having these stories, and it's one of those things where sort of in the ancient tradition of science and storytelling it's a lot easier to point out Mercury in the night sky and to remember stuff about it if you know a little bit about the character of Mercury.
That's true. And in case that didn't make it clear, this month we're talking about Mercury.
We didn't say that bit yet.
Good
I'm
introduction,
not
Beth.
with it today. So we're going to talk about Mercury because he's peeking up.
It is.
He's there in the night sky with everyone else.
To be perfectly honest, it is not the best time of
not
the year
very-
to see
no,
Mercury,
no.
but we had to get it in there because it's there in
with
the
all
parade
of the
planets.
others at the moment.
Yep.
So Mercury is the Roman equivalent of the god Hermes. Now, there's some fun stuff about Mercury. So Mercury is the god of commerce and communications and luck and travelers and thieves and boundaries.
Why do thieves get their own god?
Yeah, so it's just one of those fun
Fun facts, okay.
Well, it's one
And-
of those fun deity things. So like it's sort of translated from these like if you were anything, there had to be something to pray to.
Yeah, okay.
So
fair enough.
thieves chose a god to pray to and then became known as a god of thieves. It's the same thing with Christian saints as well. So like you have Saint Valentine, which is coming up.
Yes.
Patron saint of beekeepers.
Oh,
So
of course.
so
'cause honey is
beekeepers.
so sweet. Or something.
I have no idea why.
Yeah.
But yeah, so there's lots of like little things like that. But I think a lot of it comes from Hermes or Mercury in all of the mythological stories. It's just a little bit cheeky. So one of the first things he did as a baby, because gods, was walked out of the cave in which he was born, found a turtle shell, made a lyre, and played it to Apollo. And Apollo was like, "That's great, kid," because Apollo is a god of music.
Yeah.
So yeah, as a baby, just got up and walked out and made a musical instrument. So
Why not?
yeah, so there's some fun stuff. But so it's really interesting, this like god of boundaries thing, because the word Mercury could come from a load of different places, and this is one of those weird, like, did the name of the god come first, like, chicken egg, because it could be from the Latin mercari, which is to trade,
Ooh,
or
okay.
were traders named after the god that they worshipped.
Yeah, I see what you mean.
So yeah, it's a little so like mercari, merchant, Mercury.
Oh, well, that is plausible.
Yeah.
Yep.
Or this is one of my favorite things about language as well. There is the Proto-Indo-European is the language group that basically nearly all languages are descended from.
Right.
And in that there is a word called merg, which means boundary.
Right. Wow, it's really popping up.
Yeah. So when we say god of boundaries as well, Mercury, one of his jobs was to guide souls to the underworld.
Ah, okay.
So he was the boundary between the realm of the living and the dead. Or sometimes he's also one of the messengers.
Yeah.
So because he's the god of communication, so he's often like a messenger from gods to mortals,
Yeah.
and vice versa. So
That's
again,
how
crossing
I've
that
always
boundary.
understood. Yeah.
Yeah.
Ah,
So
there you go.
yeah, so this is also one of the reasons that I really like Mercury and find it really fitting that we are covering it this month is because Hermes, and therefore Mercury, is often depicted with little winged shoes.
Yes.
And he's often known as the god of go fast. Like he's quick.
He's quick.
Like that is
Yeah.
one of the things that he's known for. And so Mercury sort of quickly zipping across our sky, but also because Mercury is the closest planet to the sun, goes around it pretty quick.
Yeah, and that's always been my knowledge of it, because it moves so quickly in the sky. People assumed it was in a hurry, and so it was obviously running important messages for the other gods.
Yeah,
and the
exactly.
Other planets.
Now, I found out something really exciting as well. So Mercury, or Hermes, is the son of Maia and Zeus.
I did know that once upon a time.
But Maia, do you know who Maia is?
I've forgotten.
Maia's one of the Pleiades.
Really?
Yeah.
Oh, would you look at that?
So Maia is one of the seven sisters.
Uh-huh.
So they're all connected. I just love it. This is just a big storybook. The
Wow.
sky's a big storybook.
It is, isn't
It's
it?
very exciting.
Yeah, I believe I recall a scene or two in the Iliad where Zeus is on the top of Mount Olympus and he says, "Hey Hermes, go and tell Athena to stop doing that," or something, and he goes racing off down the hill, down into the battlefield, and
Yeah.
wow, there you go.
Yeah. So yeah, all interconnected.
It's all interconnected.
And that's a little bit about Mercury mythology.
There you go. Well, thank you, Beth. As I say, it's not the best time of the year to see Mercury, but we had to do it because it's there as part of the alignment.
And it's
But
going fast.
We're also going to we'll let you know when there's better times to see it.
Yes, we will.
And that's-
Although we'll probably talk about a completely different planet.
We will, but we'll throw back to this.
I also just had a thought, Leon. We're going to run out of months.
What do you mean?
Well, so in January we did Venus.
Yeah.
In February we did Mercury, but there's more months than planets.
Oh, yeah. So we're going to run out of planets.
I think we're going to have to... run out of planets, not months.
Yeah.
But yeah.
Oh, that's all right.
I think we've got some dwarf planets. I think they might have to be included.
Yeah, okay then.
Yeah.
Yeah, why not?
Yeah, all right.
We'll do that. That can be our year-long project.
Speaking of projects, we started a new segment recently,
Yes, we did.
which is
Burning questions.
Burning Question.
Burning questions.
So we asked you to send in your questions by tagging us at ParticleWA on Instagram, and you can ask us a space question and we'll try and answer it.
Yeah, or direct message us as well. That's, I think, an option.
Yeah. Slide into our DMs,
Yeah.
and away we go. And so Kirsten got in touch with us and asked the question, are the stars the same as when humans first started looking at them? In the sense that, I know we're moving through space, but is everything moving together, or do the stars shift over time? That's an excellent question.
Very good question. And it also lets Leon go on his astrology rant.
I actually wasn't planning on doing that.
Oh, no. Forget I said it. Don't worry. Keep him away.
The answer to the question is, broadly speaking, are the stars the same that humans have always looked at? Broadly speaking, yes, with a big question mark, in the sense that stars live for millions, if not billions of years, and whereas, human beings as a species have really only been around for maybe a couple of 100,000 years. And if you want to go back in time, would our sort of pre-human ancestors have been looking at the same stars, before they were even what we would call humans? Yes, more or less.
We've spoken about, Sirius was still spotted by the Babylonians, and they, and ancient Greeks and Romans saw this collection of stars of Orion as a human shape, and he is still human shaped. So in the last couple thousand years,
Definitely.
It's been the same.
Yep.
But I want to bring up the Crab Nebula.
Yes, so there's a few things that do change though. Yes, sometimes big stars go boom.
Big stars go boom.
Yes, Beth, would you like to tell us?
Well, so when a star goes supernova, we notice. Because we're so obsessed with looking at stars, we can tell when something weird happens. So there are written accounts. So this is how recent this is. And, you're assuming that also some of this will go back to prehistory, but obviously we don't have written information about that. But we have written accounts of a star going supernova, and there are stories of people being able to read outside at night by the light of this supernova, and by looking in the part of the sky that was described as where this light was coming from. When we look there now, we see the Crab Nebula, and nebulae are often indicative of a star's death.
Yes.
So, and that's in the past, past couple thousand years. We have some stars that have remained the same, and we have some that are gone
They're
now.
no longer there.
They're completely gone.
Yes. It's worth pointing out, actually, that the Crab Nebula is located inside the constellation of Taurus.
Yeah,
it's
so
actually-
Taurus might have had more stars one day.
Yeah, Taurus might have had like a pimple on its forehead or something, which is no longer there. And it's interesting. The astronomers estimate that supernovas occur in a galaxy of the Milky Way size about once per century.
So there's probably way more that have happened that we haven't noticed.
Yeah, or that maybe the records haven't survived in human history.
Maybe Canis Minor used to look like a dog.
Maybe it did, yeah. That's definitely a concept. So yes, the stars do change over time in the sense that some of them stop shining and explode or just sort of fizzle out over hundreds of thousands of years. But the other thing that really is worth mentioning is that the stars do move, including the sun. Mm-hmm. So the solar system and the sun is moving through the galaxy, as are all the stars in the sky. And this is something we can do in the planetarium. We can actually run the clock forward by 1 million years.
Which is very cool.
Yeah, and it just becomes chaotic. So what does change over time are the locations of the stars on the sky. And you can imagine that over a period of maybe a few 100,000, maybe even 1 million years, a very distant star might be too faint to see, but then over 100,000 years might come close enough to the solar system that we start to see it, and then over another 100,000 years it moves across the sky, and then 300,000 or 400,000 years from now it moves out of the line of sight and we can't see it anymore. So over the course of millions of years, the specific stars in the sky that we see do change. But over the course of thousands of years, the stars that we see, their locations change. And that's one of the fun things about being able to go 1 million years forward in the future in a planetarium is we draw up the constellations as we look now. We connect the lines between the dots, and we make Orion and we make Canis Major and Canis Minor. Still doesn't look like a dog. But then in 1 million years, if you connect physically those same stars, the patterns are just completely just all over the place.
Yeah.
So Orion looks like Orion right now,
Yes.
and the Southern Cross looks like the Southern Cross right now. But in 100,000 years, not even 1 million years, they look all different just by the location of the stars themselves.
Which is one of those things that I find really interesting, looking back at some of the histories of stars, looking back at like these historical records of Babylonians seeing the stars as this thing, and us seeing it as something slightly different, or us being able to look up at the stars and going, that doesn't look like that at all. Like, there's a number of different things that can contribute to that. So maybe some of that is the stars actually shifting out of place.
Absolutely.
Also, sometimes it's honestly light pollution. Like, I think about that a fair amount. So, like, we're talking about Canis Major and how the faint stars of the head are quite difficult to see, but they're quite difficult to see from the city Perth.
Yes,
But
from Perth.
maybe it was more commonplace for people to be able to see those fainter stars thousands of years ago when we
it was
just had
definitely,
less light pollution.
Yeah.
So, maybe it did look even more like a dog. Maybe Canis Minor, some of those dimmer stars actually do make it look more like a small version of Canis Major.
That's a really good point. I hadn't thought of that. I was
So,
wondering what you meant when you were saying light pollution. I'm like, what?
Yeah, so like the stars are the same, but Earth has changed.
Yes.
In a way that
it
means
has.
that it's harder for us to see some of the stars and to spot some of those constellations.
That's true. Do you want to know the coolest fact of all, though? At least what I think.
Yeah.
Is that how I was talking about how stars over a period of hundreds of thousands of years will move across the sky.
Yeah.
So right now we don't have what we call a southern star that sort of hangs above the South Pole. There's just not one there, whereas there is one in the North Sky at the moment, the North Star. In I think it's about 60,000 years, we will have a southern star, and it will be Sirius.
What?
Just by Sirius's motion across the sky. The astronomy term for this, by the way, is called proper motion. Just by its proper motion, in about 60,000 years, it will be in the position such that it will be sitting above Earth's south
that's
pole.
so helpful.
It won't be exactly there. It's just like, in the North Star, it's not quite exactly north either, but it'll
makes
be
a
close
teeny
enough.
circle.
Yeah.
See, because that's the thing. So from working in planetaria in the UK, we often had to make it. It's like a common mistake that people make. It's the same way as here people see the saucepan in Sirius, not in Sirius, sorry,
Orion.
the saucepan in Orion, and
Yeah.
say it's the Big Dipper, just because the Big Dipper is so much more represented in media.
Yeah.
In the Northern Hemisphere, I quite often had to distinguish for people between the North Star and Sirius, because they think, the brightest star in the sky is the North Star, because the North Star is so often associated with it's something that people can see,
Yeah.
but they're not quite sure what they're looking for.
Yep.
So they see this bright one instead.
And they think it's
So it'll be so convenient in 60,000 years for people in the southern hemisphere, where the bright one is also the South Star.
Yeah. Yeah, it's interesting actually. What is it? The North Star's like the 49th or 50th brightest
It's
star?
not very
It's
bright
not
at
very
all.
bright, no.
But it is really obviously there
Yeah.
when you see it.
Yeah.
It doesn't move around like all of the others look like they are.
There you go. But this
Yeah.
does lead on to my other cool fact, which is...
So I've seen this in our note. Okay. All that I've got in our notes for this podcast is mention dinosaurs and Milankovitch cycles.
Yeah, we might come back to Milankovitch cycles another time. But the Earth does some wobbly bits in its orbit. That's some Milankovitch cycles.
All right.
But the thing to mention about the dinosaurs is that, so as I said, over hundreds of thousands of years, the stars come and go. Over millions of years, the entire galaxy is rotating, the Milky Way galaxy. And so it takes the Milky Way galaxy about 200 million years to go around once. And when the dinosaurs are around, between 65 to 250 million years ago. So dinosaurs existed on the other side of the Milky Way galaxy.
Oh.
Which is like, once someone points it out, it's like your mind is blown. And it's so obvious, but it's not a thought that you would think of.
Whoa.
And they obviously would have had very different constellations to us today.
Yeah. That's pretty cool. Oh. Now I want to be a dinosaur again. I say again because I go through stages of wanting to be a dinosaur. And that might
not like you were a dinosaur.
No. Although, like, if you talk about, preservation of atoms and stuff, bits of me have been a dinosaur.
Yeah, probably.
But just like, once in a while, you're just like, it'd be cool to be a dinosaur. This is now, I want to be a dinosaur so I can go look at what their constellations were.
All right. So, excellent question there, Kirsten.
Yeah, thank you.
And yes, keep them coming. As we said, tag us on at ParticleWA on Instagram or slide into our DMs.
So, we spoke of the planetarium and what we can do in it. So I think, meanwhile, in the SciTech Planetarium.
Meanwhile, in the SciTech Planetarium.
What's going on?
Do we have a stinger for that?
Meanwhile, in the SciTech Planetarium.
What are we doing? Leon's doing exciting things in the SciTech Planetarium. This is really like...
Just more of an update.
Yeah.
Just to know that we do work behind the scenes. We're not just constantly getting through shows and showing people what we're doing in the night sky in our live shows.
No.
We're also
changing light bulbs.
Yeah.
This morning. That was fun. How many planetarium presenters did it take to change a light bulb?
That's
2.
Yeah, that's true.
Wearing extensive PPE.
Beth is trivialising the process of changing over the lamps for the projectors. We have to have some very powerful lamps to power our very large and very powerful projectors. And,
as in like genuinely there are warnings on doors for do not enter because this thing could explode.
Yeah. So, we put our gloves on and our masks and aprons, lead vests.
Mm-hmm.
No, not lead vests, but...
I was going to say, you did not tell me they were made of lead, Leon.
Welders' aprons, Kevlar gloves, the whole shebang.
Mm-hmm.
But the other two things I want to talk about is that we've been working on a nice little new show. It's called A Little Trip to the Moon.
I saw a little sneak preview this morning. It's so cute.
Yeah. Now, to be fair, that it is aimed at early childhood. This might be the wrong podcast to be plugging it, but I'm going to talk about it anyway.
Some people have kids.
Oh, that's true. Oh, yeah, I forgot about that.
People have children.
I was never a child. I just kind of sprung out of the walls in my mid-20s.
I would believe that.
Yeah. But yes, so we have Toddler Fest upcoming, which is a 2 or 3 week festival aimed at little kids, and we've decided to bring out a new show in the planetarium that we've made it in-house, and it's all about going to the moon. And you won't be able to see it anywhere else. And we storyboarded it, we programmed it ourselves, we land on the moon, we plant a flag, we pick up rocks to do science, and it was a lot of work. Collectively, the planetarium contributed a lot of ideas for it, and then I did a lot of programming, and then I'm going to handball it to our content team to do the audio and the music for it.
Does the content team know about that? Just looking at the producer. Okay, he knows.
He does now. So there's that. And then sort of a precursor for what I'll probably talk a little bit about next episode is I'm flying out of Perth tomorrow. I'm heading over to a place in Queensland called Charleville for the National Planetarium Conference, which, to be to strictly clarify, it's the Australasian Planetarium Society annual conference.
Okay.
And there's a bunch of planetariums from Australia and New Zealand participating, and we have it in a different location every year. And this year we're having it in the middle of nowhere in Queensland.
That's very fun. You're going to get some great stars.
Yeah. Oh, yeah. That's definitely on the schedule. There's a lot of stargazing and things like that. But yeah, these are just really interesting conferences because as it's very strange working in a planetarium. There's only like 10 planetarium employees in all of Western Australia, and they're all here.
Yeah.
So it's kind of hard. You can't like go and compare notes with anybody else from another business because there's no one else in Western Australia that does what we do.
It's that interesting thing when it comes to business in general, where like a little competition can be beneficial to everyone involved, actually, because it means that you've got that like someone to mark yourself against, but then also you do have that camaraderie and like being able to share experiences, go, this is working, this is not, or like, how have you found this, so us being all on our lonesome out here in Perth can sometimes be a bit isolating.
Yes, that's right. And so that's the point of this conference in Queensland next week.
Tomorrow,
my goodness. And so that's the purpose of this conference that I'm going to, is to chat with all the other planetarium operators from around Australia and to, see what's working, see what's not, see what they're thinking of doing. And but the other advantage is because they're in different states and have different business models, there isn't really competition. It's very much it feels like you're meeting old friends.
Oh, that would be nice.
So I'll tell you all about it. Yeah,
hopefully some interesting space information.
Yeah, and some stargazing. We'll see. So watch this space. We'll have an update on that soon.
Was that deliberate? Was it space?
Yeah. That was a good one.
Yeah. All right. I think we've got one more section.
We have one more section.
This is a quick section.
Yeah, it is.
Okay. What have we got left to talk about, Leon?
We've got space flight focus.
Oh.
2, 1. We have a liftoff.
I just thought this was a good opportunity to talk about Jupiter. Really.
Oh, okay.
Yeah, that was it.
Oh. How is he?
Yeah, it's all right, I think.
All right, good.
That's it for this episode.
He's doing all right.
So, orbiting Jupiter, there is a spacecraft called Juno.
Yay!
Which you can tell us Juno is Jupiter's wife, is that right?
It's so funny. Scientists do have a sense of humour. Jupiter, the planet, has a bunch of moons. All the moons are named after Jupiter's mistresses. NASA sent a space probe up to keep an eye on Jupiter and his mistresses and named it after his wife.
Excellent.
Yeah.
That's a wicked sense of humour if there ever was one. And so Juno is mainly studying Jupiter, but every now and then it flies close enough to one of Jupiter's moons to get a good look. And
keep an eye.
Yeah, keep an eye. And by looking at some of the latest data from the moon Io, astronomers have noticed that Io had an absolutely traumatic volcanic eruption in the last 12 months, which is quite interesting. So Io is already the most volcanically active place in the entire solar system, and this new eruption was discovered. It took basically all of last year, and during the last 12 months, Juno flew past Io 3 times, and there's this volcanic spot on Io that wasn't there 2 years ago and is there now, and it's about the size of maybe 50% larger than Tasmania. This entire region of the moon has just been reshaped by this enormous volcanic eruption.
Whoa.
And they're able to estimate the power output of this volcano, and it's about 6 times the entire world's energy consumption constantly. So just spewing energy out of this massive volcano, bigger than Tasmania.
Can we have some?
It'd be nice, wouldn't it?
I was going to say, you said it was traumatic, and I was going to make a terrible Greek joke, a mythology joke.
There's already enough traumatic Greek.
Is it as traumatic as being turned into a cow, which is what happens to Io in the mythology?
Right. Look, maybe.
I mean, to be fair, I think 6 times the energy requirements of the planet Earth constantly might be more traumatic than being turned into a cow.
I
for
think
a moon.
Watching the kids turn into donkeys in Pinocchio was traumatic enough.
That was, no, maybe not.
Yeah.
Really incomparable.
Yeah. But it's interesting because, where is all this energy coming from? And it's actually coming when you trace the breadcrumbs. Really, it's coming from Jupiter's own gravity. So as
is this a squeezin'?
Yeah, it's a squeezin'. As Io orbits Jupiter, its orbit is not perfectly circular. it's sometimes closer to Jupiter and sometimes further away, and therefore it feels more and then less gravity from Jupiter, and back and forth, and it squeezes the moon from being shaped like a volleyball to being shaped like a AFL football. It's not that dramatic, but that's just the visual I want you to have in mind. And as it does that, there's an enormous amount of friction that gets generated inside Io. We call these tidal forces. And it's the same thing that happens on Earth and the moon to a much smaller extent. In this case, the moon's effect on the Earth is not very much, and Earth is rock is very brittle. But water is not, which is why the water sloshes around and we get high tides. But Jupiter's gravity on Io is so strong, the rock behaves like the tides on Earth. And that energy then drives these volcanoes.
That's very exciting.
Yeah, so I just thought that was a pretty cool thing to mention.
It's a pretty hot thing to mention.
Yeah, true.
Is it hot though?
Yeah, I don't actually know the temperature off the top of my head, but
because we're a very long way from the sun.
Well, yes, again, that energy is coming from Jupiter, though. Jupiter, the sun is the sort of secondary effect in the dynamics of the Jovian system. All of that energy is really from Jupiter. Jupiter drives its own mini solar system, I guess you would call it, which is pretty cool.
That's very exciting.
So that's all I've got to cover for that.
Yeah. Thanks, Leon. That was awesome.
I think that's everything.
Yeah, pretty much.
Well, I've had a time and a half, Beth. Thanks for being here.
Thank you for having me.
And thanks for listening, everybody. That's it for this episode of Please Look Up. We'll see you next month where we talk about the night sky and the space news for March. If you want to hear more interesting space news, check out the website particle.scitech.org.au for more information.